In this lecture, we will learn about finite state machines in the Panda 3D game engine. A finite state machine is a computer science concept that means any system which has a finite number of states, and a way to transition between those states. Later in this section, we will build a 3D Sonic the Hedgehog game using Panda 3D and Python code. For now, we will see how to set up a finite state machine that lets Sonic move between two states, jump and punch. We can visualize our state machine like this. There is a jump state and a punch state. There is a way to transition from the jump state to the punch state, as well as a way to transition from the punch state to the jump state. The first step before we write any code is to download the Sonic model file attached to this lecture as a course resource, and drag and drop it into our My Stuff folder, housing the Python file we have been working with in this section of the course. Now we can jump to PyCharm and start coding. Up at the top of the code we will have several import statements. We will type from direct.showbase import showbase, from direct.actor.actor import actor, import simple PBR, import GLTF, from direct.fsm.fsm import FSM, and import threading. Next we will create a variable named Sonic, which will be the animated character or actor that we will use in our program. Let's set Sonic equal to an actor object with a model of sonic.blend, the file you downloaded attached to this lecture. The second argument is a dictionary with Sonic's animations and the model they are stored on. The first item will map the key fpunch to the value Sonic blend, and the second dictionary item will map the key fjump to the value Sonic blend. Then we will use the class keyword and create a class named Sonic FSM that extends Panda 3D's FSM class. Inside of this class we need two functions for each state. We name the functions enter, and then the state name, and then exit, and then the state name. We will use the def keyword and create a function named enterPunch. Inside of this function we will type sonic.loop and pass in the string punch, which tells Sonic to play the punch animation and loop it after the animation finishes playing, meaning it starts over again. Next, we need to create an exit punch function responsible for exiting the punch state. Inside of this function, we will call the stop function on Sonic, which will stop the punch animation that is running on it. Then we will do the same thing for the jump state. We will create an enter jump function, inside of which we will loop the jump animation, and then an exit jump function that calls the stop function on Sonic to exit the jump state. After that, we will create a class named myApp, which extends the showBase class. Inside of this class we will implement the init function. Then we will call super.init. Next we will call simplepbr.init. After that we will call gltf.patchLoader and pass in loader. These three lines are to enable our own lighting instead of the default lighting. Next we will disable the mouse by calling base.disableMouse. After that, we will set the background color to black by calling base.setBackgroundColor and passing in 3 zeros. Then we need to set the position of the camera by calling camera.setPos and passing in 0 as the first argument, 0 as the second argument, and -2 as the third argument. Next, we will call camera.setP and pass in a value of 90. This sets the rotation of the camera to 90 degrees. Then we are going to make some adjustments to Sonic. He comes in pretty big relative to the camera, so let's call setScale and set it to 0.5 in each direction. This simply means that Sonic will be half the size of the original model when he is rendered to the screen. Then we will reparent Sonic to the render node. Next we will call Sonic.setHPR and pass in 90 as the first argument, 0 as the second argument, and 90 as the third argument. Then we will type self.SonicFSM and set it equal to a SonicFSM object, with the string Sonic passed in as the name. After that, we will call self.handleStateChange, a function we will write now. Let's create a function named handleStateChange. Inside of this function, we will call threading.timer and pass in 4.0 as the first argument, and self.handleStateChange as the second argument. This tells the program to wait 4 seconds and then call the handleStateChange function. We also need to add a call to the start function at the end of this to start the timer. Note that all FSM objects have a .state property that holds the current state that an actor is in. We will have an if statement that checks if the Sonic FSM's state is equal to punch. If it is true, we will call self.sonicfsm.request and pass in the string jump. The request function is how we will tell the state machine to change states. So this line of code is telling Sonic's FSM to change to the jump state, Else we will type self.sonicfsm.request and pass in the string punch to change Sonic to the punch state. Finally, we will create a variable named app and set it equal to a myapp object. Then we will run the app by calling app.run. Note that the run function in Panda 3D starts up the main loop for the game. When we run the code, you will notice that Sonic starts out throwing punches. After 4 seconds, he switches to the jump state and starts jumping. 4 seconds after that, he goes back to punching, and this repeats over and over again thanks to our finite state machine. In the next lecture, we will learn about the rendering process in the Panda 3D game engine.